All right, last one, you guys. This seems to have taken forever. 9-4, lesson on rotations. I'm on page 125. I'm not going to work on this page because, as you can see, it might be a little hard to view. I do want to be sure that you read, though, what it says. It says... we want to learn about rotational symmetry. We need to learn about the angle of rotational symmetry. And on these, what are your directions? Your directions are identify if it has rotational symmetry or reflectional symmetry, or both, and then find the angle of rotational symmetry. Okay, so I have taken these shapes and blown them up so that they're a little bigger. So know that that's where these shapes come from. The first thing I'm going to do is review lines of symmetry. So we remember lines of symmetry. I think I need to make that darker. Lines of symmetry are lines that divide the picture into two equal parts. Okay, so this is an isosceles triangle. So I know that this side is equal to that side, and I know that this angle is equal to that angle, and so when I fold that over, it'll match perfectly. This is an equilateral triangle, so it also has lines of symmetry. Okay. And we have a rhombus down here. Now, I'm going to be honest with you. This does not look like a rhombus to me. It looks like a parallelogram, but the book says that it's a rhombus. It names it a rhombus. So you're going to have to be careful here and understand that a rhombus means that all the sides are the same length. I think these two sides are longer than these two sides, but we're going to go with what the book tells us, that all the sides are the same length. If all the sides are the same length, that's going to be a line of reflection, because this side is going to map to that one, and this side's going to map to that one, and they're going to be equal. Okay? Well, if I can do it that way, then I can also do it this way. Okay, so this side's going to map to that one. When I fold it over that line, this side's going to map to that one, and they're the same size. This side's going to map to that one. So I've got two lines of symmetry. And then down here, I have this one, I have this one, and this one. And some of you may be thinking, that's it. No, not on this one. We can also go from midpoint to midpoint. So I've got a bunch of lines of symmetry here. Okay, so the direction said identify if it has line symmetry. Well, if I've drawn in a line of symmetry, I've identified that it has. So all of these do have line symmetry. Okay, so the next thing it wants me to do is identify if it has rotational symmetry. Well, I'm going to go to this one first, because did you notice that all three, in every one of these cases, the lines of symmetry always intersect at the same point? That point is going to be considered the center of your rotation. So I've taken my patty paper, or my baggie that I cut up. I traced the outline, and I put a dot in this one corner, because what you're going to see is when you rotate it and it maps to itself. Are you watching it? I'm rotating it. And when I say it maps to itself, I get right here, and the trace matches again. Well, that's one mapping, but I haven't gone all the way around, because do you see my dot? There's my dot. So I've mapped onto itself one time. I'm going to keep going. I see that it's going to map to itself a second time. And then if I keep going one more time, it's going to map to itself a third time. That's important. It takes 3 turns to map to itself. So the way you find the angle of rotation is you always take 360 degrees. Do you know why 360 degrees? I keep forgetting. You can't read that, my pen, very good. So your angle of rotation, the angle of rotation is equal to 360 degrees divided by the number of mappings. 360 degrees is because that's all the way around, and I did it 3 times. I went all the way around 3 times. So you take 360 degrees, divide it by 3, and that means my angle of rotation is 120 degrees. So that means to get from here to here is 120 degrees, from here to here is 120 degrees, and then to go back around again is another 120 degrees. Okay, so this one there's no intersection, so we don't have a center of rotation, but I think you can see that as we rotate it here, it's not going to map back onto itself until we get all the way around. So since this one doesn't, we have to go all the way around to map back onto itself. This one has no rotational symmetry. All right. So we have our rhombus down here. We rotate it this way. Not yet. But we rotate it. See, I think that's, I forgot to put the little dot. Let's put the dot. We should be able to get it. There we go. Yeah. So there's one time that it mapped itself. Let me hold it down so it's easier to turn. There's one time it mapped itself. And then there's another time that it mapped itself. All right. So it takes 2 turns. So you take 360 degrees, divide it by 2, because I had to turn it twice, and we have 180 degrees for our angle of rotation. All right. Here's another one. It had a whole bunch of lines of symmetry. We found, I bled. Got a little, ignore that stuff in the middle. So I'm going to put a dot in one of the corners so that I can count how many times it maps onto itself. There's 1. There's 2. Move it up a little bit, maybe so you can see. There's 2 times. There's 3. There's 4. There's 5, and there's 6. So the angle of rotation can be found by taking 360 degrees, divide it by 6, because it turned 6 times. So the angle of rotation is 60 degrees. Okay, and then you don't always have just plain normal looking objects. We could have something similar to this. Okay, you can still identify whether it has line symmetry to find out where the center of rotation is, but sometimes with designs it's pretty obvious to see. I put the 1, 2, 3, 4 in there so that we could tell the difference, and then I forgot to, so let me do, this is 1. All right, so as I rotate this around the center, here it is. Oops. Okay, so we see the image maps back onto itself, but it does not, it's not completely back around, because here's my 1, that's right here. So it turned 1 time, mapped 2 times, mapped 3 times. It takes 4 turns for that 1 to show back up where the original 1 is. So what would be the angle of rotation? 360 divided by 4 times, mapped 4 times. That would be 90 degrees. So the angle of rotation for that one would be 90 degrees. I have a page that has some interesting shapes. I will post this for you, and maybe along with the answer. so that you can get some extra practice beyond what's in the Springboard book. So in my next video, I will be going over answers, okay? In my next video, I will be going over answers.